All right, here's the reaction between zinc, solid zinc, and we're going to call this aqueous iodine because it dissolves in water, although it's a little more complicated than that, to create ZnI2, which at first is aqueous. And let's balance this reaction. Done. Okay. What happens is zinc has 2 valence electrons. Iodine is one of those Brinkelhoffs. It has 7 valence electrons, and it's only happy when it's bonded to its twin. So this is so it's always as I2. What happens is that zinc has 2 electrons that it really doesn't want. It wants to have a noble gas configuration, just like the noble gases. Iodine is happy sharing electrons, but it would rather have them by itself. So you put these in the room together, you add a little bit of heat, get the right music going, and what happens is that this zinc gives one of its electrons to iodine, and then so I'm just going to put it right here. Okay. I'm doing that because it gives it to iodine, and then it leaves this, so it breaks off with that iodine. Now this zinc gives another one to this one. And what you're left with is this iodine here now has a negative charge because it has an extra electron. This one here also has a negative charge because it has an extra electron. And this zinc has a +2 charge because it's lost 2 electrons, which are negative. So what happened here is that this zinc gave its electrons to iodine. This is a loss of electrons, which is also called oxidation. Why? Because oxidation usually steals electrons. So it's named after the nefarious oxygen. This is so this is losing electrons. Iodine is gaining electrons, and that's called reduction. Why? Just to confuse you, because it's gaining electrons, it's reduction. No, because actually this oxidation number goes from 0 to -1, so it gets reduced. That's lame. Just remember Leo the lion goes dirt. So once again, this gives off the electron to this and this. What happens is that this used to be solid, now it becomes ionic, which dissolves really nicely in water. Same thing with the iodine. You've got 2 ions, 2 anions of iodine, and they're negative, and they're all dissolved in water. The solution's clear. If you evaporate the water, add a little bit of heat, you'll end up with the white solid, which is also known as zinc iodide. Okay, so it's zinc iodide because it's an ionic compound. You don't have to say diiodide because we're lazy, we don't want to say it. We know that this has to be +2 charge, and this has to be -1, there's 2 of them. There it is, zinc iodide. You got it? I'm going to show you the reverse.